So, for these next bits, we're going to be discussing about the universe entirely. There's going to be pretty much no mathematics in it. So, if you like the mathematics part of physics, you can stop now if you're not interested. But here we go with some actual universe stuff. So, the theories about how our early universe actually began, there's plenty of theories, but the one that most people have heard of and the one that's most widely accepted is known as the Big Bang Theory, not the one featuring Sheldon Cooper, unfortunately. So this theory postulate just tends to be like theory or thought, that a universe was originally a microscopic speck of negligible particles, so just a bunch of sort of random particles, sort of floating, known as a singularity, which sort of exploded over a very short amount of time. So this very small or infinitesimally small period was known as cosmic inflation. It's been theorized that in order for a universe to expand how it is, the inflation actually was meant to last about 1 by 10 to the negative 30 seconds, which is just incredibly short. So, in this video, I'm also going to be discussing two other theories on how the universe started. But first, we're going to talk about what happened after inflation. So, this was actually a good inflation, not financially detrimental. So a huge amount of energy was released, which actually caused the formation of protons, neutrons, and electrons. And because of that, it formed both the strong and weak nuclear force along with it to bind the individual particles together. So once the strong and weak nuclear forces were made by this period of inflation, they began to coalesce and combine to form atoms, which later, when the atoms start to form with each other, they formed stars and planets. So, in tandem with this thing known as Hubble's law, which we'll discuss later, but in short, it's the universe expanding quicker and quicker. The astrophysicist Georges, I couldn't find his last name through my research, said that the universe could possibly be traced to an infinitely small point, which also matched Hubble's law. So, that infinitely small point expanding is sort of like if you imagine the universe compared to a giant being, having it be an infinitely small point. They'll witness sort of the same expansion. So generally, the Big Bang Theory is the most agreed upon. However, there are two other theories proposed that actually got a bit of traction before the Big Bang Theory was sort of widely accepted by science. The first of which is known as the steady state model. Now, the steady state model says that the density of the volume remains identical throughout the continuous expansion of our universe. So as the mass increases linearly, what they're saying is that the volume increases linearly to keep the density, the average density of the universe, the same by sort of the conservation of mass in a way. So it was actually popular during the mid-40s and the 60s. However, once World War II ended, science was, sort of rapid with all the Cold War developing nuclear arms and stuff, or new nuclear technology. So the theory is now rejected by experts in the field, though it was preferred over the Big Bang Theory sort of in its early heyday, before the Big Bang Theory research came to fruition. Now the third alternative theory, so the alternative, was known as quasi-steady state. So quasi essentially means like fake almost. It's sort of in the same realm as the word faux. So you might actually see this as well as faux steady state, so FAUX. And it was an amendment to the steady state theory which sort of allowed modeling assumptions to sort of take over. So microbangs, which can cause the universe's growth to accelerate quickly through what's known as jerk. Jerk, if you didn't know, is actually the third derivative of position, so it's the change in acceleration. So what it's saying is that the acceleration, or the accelerated growth of the universe is not constant. And so these microbangs are points where the jerk actually appears and is non-zero. So the quasi-steady state, or the faux steady state, is, well, rather obviously critiqued and discounted by many experts, but again during the 40s and 60s, when the Big Bang Theory was not really greatly researched into, the both steady state model and the quasi-steady state model were essentially the agreed upon ways on how the universe began.